Hello, everybody. Today we are back at it again. This is the live office hour hosted by Chegg, brought to you by Chegg. We will be doing trig and precalc, and today I would like to focus on the range of a function for precalculus level, because to find the range it's actually not easy at all. But yeah, this is the first question that I would like you guys to try. Anyways, though. For the people who are just here already, then go ahead and try the question and then just kind of enter the answer in the chat and let me know what you guys have. And then in the meantime, let me just say hi to the people in the chat. So thank you guys so much for coming here today. This is the live office hour brought to you by Chegg. And for the people who don't know, make sure you guys go scan the QR code right here so you guys can check out what Chegg has offered for you. Today, we'll be focusing on the range of a function, and I will just kind of like showcase or go over all the things that you should know at the precalculus level. Because last week we did a domain, and then we'll be back again next week. We will have the live on Mondays from 6:45 p.m. to 7:45 p.m. Pacific time. So right now we just got started, and then we'll go for an hour, and let's see how it goes. And by the way, if the audio somehow just didn't work out well, like last week, I apologize. Last week there was a lag in the audios. Please just like leave in the chat and let us know. Right now, I'm not using a mic, so hopefully that should be better. Hello, everybody. All right. Hello, Chris. Hello. All right. So go ahead. Let me know. Okay. Let me know what the answers is. So the live office hour will be back next week. I think I'll just be hosting the live office hour on Chegg's YouTube channel. So make sure you guys go subscribe to Chegg's YouTube channel so that way you guys can join the live next week. All right, so here we go. Let's just go ahead and do this very standard question. Firstly, though, there are only certain types of functions that you have to know how to handle in order to find the range. For the domain, it's easier, but for the range, it's much more difficult. If you don't have a graph, then these are the things that you should know. First, you should know how to find the range of a quadratic. Linear is just like straight line, it's just all real numbers, so you don't really have much to do. But for the range, firstly, notice how here we have a quadratic, so the graph is going to be a parabola. So here's just a quick review. A parabola, either it's going to go open upward like this, or open downward like this. Maybe this right here can be more down, or maybe this right here can be more up. I don't know, but I will tell you one thing though. We will have to find the lowest and also the highest point. The good thing is that the vertex is always going to be at x equals negative b over 2a. Same thing for this picture. X equals negative b over 2a. But we will also have to know if the parabola opens up or down. It's just one simple check. Look at the a value. If a is greater than 0, then opens up. If a is less than 0, it opens down. So to get a range for this right here, first we'll have to know the vertex. The vertex is going to be at x equals negative b over 2a. So if you work this out, x is going to be at negative b, which is 4, over 2 times a, which is negative 2. Work that out, that's negative 4 over negative 4. So the vertex is going to happen when x is equal to 1. I know, I realized that too, 1. That's not the answer though. The answer is not B, the answer is not C. No. Because the range, it's about the y values, right? And as we can see, we have a negative a value. So we are talking about this situation. We will have a maximum, and then the y value will go from negative infinity up to whatever that is. But let's go ahead and just find out the y value. The y value Once we have the x, we can just plug it into the original. This is the same as the y. So plug that in, we have negative 2 times 1 squared plus 4 times 1 and then plus 1. 2, negative 2, 2. 2 plus 1, we get 3. So the graph is going to look like this. This is just a quick sketch of the graph. The first x is going to be at 1, 3. 1 right here, and that's 3 right here, something like that. And then it's going to be opening downwards, so just like that. So the graph will look like this. It's slightly narrower because this coefficient here has the absolute value bigger than 1, so it's slightly narrower. If it's an absolute value of the a is less than 1, then it's wider. But something like that. And the y value here is 3. So the domain is all real numbers. There's nothing to worry about for this right here. But the range, in interval notation, we go from negative infinity up to 3. So just write it down like this. And we are including 3 because it's possible for the y to be equal to 3, which just like this. So the first case that you really have to know is to find the range of a quadratic, just like that. All right, now we have a lot more people in the chat. So hello, everybody. If this is the first time that you are here, welcome. If you have been here before, welcome back. If you have been here before, just drop me a me in the chat and let me know. And by the way, how about let's do this? So that way we have a nice record. How many times have you joined the live streams? Because I think so far we have done like 8, something like that, or 7. How many times have you joined the live stream? If this is like the 3rd time, just enter 3. If this is like the 5th time, just enter 5. If this is your first time, just enter 1. So it's just like a quick survey. Thank you guys so much. And I will tell you that next week, I don't think we will have the live on my channel. It will be hosted on Chegg's channel. So make sure you guys scan the QR code. So it will take you to Chegg's YouTube channel so that we can also join the live stream next week. We can just go to YouTube and then search Chegg for the official channel. All right? All right. Thank you guys so much. Wow. Many of you guys have been here multiple times. And for the people here who are here for the first time, thank you. Any questions on this though? If you have any questions regarding to the things that we are talking about, please just drop in the chat and let us know. And also, if you're doing similar things in your pre-calculus class or trig class, also let me know. I will also be doing a trig example later on, all right, for finding the range. And now, I'm going to show you guys the next case, the square root ones. So it's just all about finding the range for today. So let's say we have a square root function. Let's do this right here. Let's say we have 2 square root of x minus 1 plus 3, something like that. Let's keep it simple. Okay, let me see. Cool stuff. This is what you're teaching at teaching your students. Oh, cool, nice, very nice. Yes, we can use dy dx to find the maximum value, but we are going to keep it with pre-calculus level, so no derivative. That's why I used the vertex formula earlier. Anybody want to give it a try for this one? What's the range? Right, it's all about the range for today. So let me just write this down. What's the range of this function? And we are going to write it in interval notation. Interval notation. All right, I'm going to go over when somebody puts down the correct answer, so let me know. For little bonus, you can also put down the domain. We went over domain last time, so today we're going to go over the range. Hello, everybody. Hello. 3 to infinity? Yes. And we are going to use parentheses for interval notations for the infinities. We are going to use bracket for the 3 because we are going to be including the 3. All right, so this is a summary that you should know. It depends on how complicated the inside expression is for the square root. I will tell you. So first, you have to know that when you have square root, if the inside is just a very nice expression, what I mean by that is just linear. So I'll just say ax plus b, right? This whole thing here, it will be non-negative. The output of the square root is never negative, right? But it depends on the inside because you also have to make sure the inside will actually be 0. So a linear will work. If you have a quadratic, you actually have to do what we did earlier, and then you enter in the square root. So it's slightly more complicated. Maybe that will be a good topic that we go over next time. But today, it's just for the simple functions, meaning linear functions. So if you look at this right here, this portion is going to be greater than or equal to 0. And when you multiply that by 2, this right here will just be greater than or equal to 0 because it's 2 times that quantity. And of course, after we add a 3 to it, 2 times square root of x minus 1 and then plus 3. All this, because this part is greater than or equal to 0, add a 3 to it, this will be greater than or equal to 3. And then we're done. That's it. You can also utilize the graph, but if you are in a hurry, then this is all you have to do. So the range will go from 3 to infinity, including the 3, but for the infinity, you always use parentheses. All right? Now, here's a domain. If you want to find the domain, you look at the inside. Yeah, for the domain, you just have to set inside the x minus 1 to be greater than or equal to 0. So x is greater than or equal to 1. So for the domain, it goes from 1 to infinity. And if you want to do a quick sketch of the graph, this is how you can do it. You should first know about the square root of x, which looks like this. This is just square root of x. Subtract 1, meaning we are going to move to the right 1 unit. So this right here, we will get something like this, 1 and like this. This is square root of x minus 1. If you multiply this by 2, it's just going to give you a higher y value. So it's like this. This is 1. And 2 times the y value here is 0, it's still 0. And it's going to just get taller. So that's 2 square root of x minus 1. Right? And lastly, when you add 3, you are going to bring this graph up 3 times. So I am just going to erase this part right here for you guys. So these right here are the intermediate steps. And finally, for that, if you want to make a graph, it will be 1 here and 3 here. Yeah, 1 comma 3, just like the one we got earlier. Yeah, and then like this. So that's the graph for 2 square root of x minus 1 plus 3. That's why the range is from 3 to infinity, and the domain is from 1 to infinity. If you have the graph, domain range should not be an issue. But the problem is when you have just an equation, you need to be able to know how to do it. Now, be really careful though, if the inside is not a linear, you will have to really, really be careful with it. So this right here, it's slightly more difficult. If you have a x squared here, then it's going to be different. It's different, right? But anyways, though, why don't you guys give me a try, and then let me know what you guys have for the answer. Yeah, I just changed it to x squared minus 1 in the square root. Well, actually, no. This right here is still okay. This right here is still going to give you plus or minus. Sorry. I'm going to just change the function. I shouldn't be that lazy. Let's put down what we did earlier. Let's do this. How about let's do this? Let's do 2 times the square root, and let's do x squared. And I want to do plus 2x. And then, hold on. And plus 3. And then plus another 3. Okay, there we go. All right, now do this one. Earlier, the one that we have earlier, square root of x squared minus 1, when x is equal to 1 or negative 1, you still reach 0. So this right here is still going to be greater than or equal to 0. So it's the same range like the one I showed you guys earlier. But if you have a quadratic inside here, you really have to be careful. So now we're just combining the first example and also the square root case together, and let's see what you guys have. So for this kind of questions right here, some of you guys might have done it back in algebra 2, right? Algebra 2, and later on we're getting to the precalculus level once you talk about the exponential functions and also logarithm functions. All right, let's have a look. Right here, we have to find the minimum of the inside first. So we need to get the minimum of x squared plus 2x plus 3. And let's just be consistent. Let's use the vertex formula that we did earlier. So the vertex is going to be at x equals negative b, which is 2 over 2a, which is 1. So the vertex is going to be at negative 1. And the y value, it will be at negative 1 squared plus 2 times negative 1, and then plus 3. So what's that? That is going to be 1 minus 2 is negative, so it's 2. Okay, so that's 2. All right. So if you look at the graph right here, just this part in red, the vertex is going to be like this. X is negative 1, y is 2. So we have negative 1 and 2 right here. And the coefficient of x squared is positive 1. So it opens upward. So we have this and then go up like that. So that means for the inside, this portion here, right? This portion here, it's always going to be greater than or equal to 2. All right? So this right here is the hard part with when you have a function composition and you want to find the range. You really have to dig inside first and then just kind of make you just have to investigate and then put things together. So for this right here, I will just write it down like this. So we have 2 square root of the inside, which is, how should I write it? Okay, how should I write it? Oh, I'm just going to write it like this. So this inside is going to be greater than or equal to 2. So this means the whole thing will be greater than or equal to. We still have the 2 right there times the square root right here, but this is greater than or equal to 2. This part is greater than or equal to 2. And then just add 3 to it. And that's it. You can see that this function is always going to be like this. And by the way, this right here works because the square root function is an increasing function. So I should say, note, the square root is increasing, right? So that means when the inside gets bigger, the output gets bigger. That's why if the inside right here starts at 2, once the inside gets bigger, then the whole thing will get bigger. So it will be like this. So the range for that, it will go, this is the minimum now, which is 2 square root of 2 cannot really simplify anything. Plus 3, and then comma infinity. It's possible to be equal to this number, but you don't include infinity. So that would be for the range. Okay. So now we have gone over the square root function and also the quadratic functions. For the cubic, it's all real numbers, so nothing too much that we can talk about. Let me just go to exponential and also logarithms. For exponential functions, let me just give you guys a quick review. So for exponential functions, let me write it down right here, exp functions. If you look at the function f of x equals, this is the standard form. You have some number a times some base b raised to the x power. We have some conditions for the exponential functions. First, the b right here has to be positive. That's just by default. You don't want to have negative base. Otherwise, you're not going to get a graph if x is negative. So b has to be positive, but in the meantime, b cannot be equal to 1, because otherwise 1 to the x power is just always going to be 1. So it does not change. It's not an exponential function like that. Here, for the exponential function, x can be anything. And then this right here can also be anything. The a can also be anything. Doesn't really matter though. Okay. Now, if you just look at this right here, b to the x. If b is greater than 1, then you are going to get this. Let me see if I can. Let me just get that maybe. Okay, I'm just going to try to do a smaller one like this then. If b is greater than 1, you get an exponential growth function like this. Thank you. And then this right here, the range, let me just write it down. You do not touch 0, right? You do not include 0, but it goes up to infinity. So it's not including 0, but it does get to infinity. You can also write it as y is greater than or equal to, y is greater than 0. And even if you have, let's put this down in blue. If you have b is less than 1, but it has to be positive, then in this case, you just get an exponential decay function, which looks like this. Now guess what? The range is still the same from 0 to infinity, not including 0, but we have infinity. So let me just write this down real quick. So 0 to infinity, not including. All right? Let me see if I have my, I do. Okay, so coming up next, I'll also put on a log function that you need to know. This is the exponential function, just like this one, yeah? Ready? Take this. We're going to flip the diagonal like that. That's how we get a log function. So for the log function, I'm just going to write down the inverse for this. I'm just going to give you guys this one right here. If we have y is equal to log base b of x, and right here, let's just say base b is greater than 1. I'm just taking this right here and do the reflection, and I get a log function. The graph looks like this. Okay, so that's a log function. And then as you can see, the range for this right here, and perhaps I'll write down domain. The domain is all real numbers, but the range right here, let me just write this down. The range right here, it's all real numbers. It goes from negative infinity to positive infinity. You never include infinities, so you always use parentheses for that. Okay. Okay, let me take a look. So far, are we okay? So let me know. So in general, we will have to be careful with exponential functions because the range is not everything. But for log, yes, it is. Unless we have more things inside, that is more troublesome. So why don't we take a look at some problem that we'll be dealing with? And perhaps I'll show you guys one of the questions that I just asked my pre-calculus students today on the quiz. Find the domain and range for exponential function, and this is the function. I'll write down f of x. I have 5 minus 2x minus 2, something like that. The goal is to find the domain and also the range. So perhaps I'll write it down right here. We want the domain and the range. Why don't you guys give this a try first? And then again, use what we have done before with like how you shift the functions, how you flip the functions, all the stuff. If you think about in terms of the function transformation, yeah, this is not bad at all. Right. So for the people who are here, thank you guys so much for coming. Thank you guys so much for joining today's Life is Office Hour brought to you by Chegg. We'll be back next Monday from 6:45 p.m. to 7:45 p.m. The live stream will go for an hour. You can ask me questions regarding trig and pre-calc. For today, we are going over how to find the range. But if you have questions from your homework or from study, feel free to drop them in the chat, and I will try my best to answer your questions. I'll try to do as many as possible. For next week, though, I will be hosting the live stream on Chegg's channel, so make sure you guys scan the QR code because you're not going to see the live on my channel. You will have to go there in order to join the live stream. Domains all real numbers. Yes, that is very easy. Okay, and then how about the range? Give you guys like a little countdown. 5, 4, 3, 2, 2, 1. No, it's 5. Because here's the deal. The maximum, you don't reach the maximum, by the way. It's at 5. The range is going from negative infinity to 5. Not including the 5, though. Be careful. Not including the 5. Not including the 5. So this is how you can do it if you want to do the graphical approach. Okay, so starting from 2 to the x, this is what we know, 2 to the x. And this is 2 to the x. And then we have this point right here, right? Next, we are going to subtract 2. So that means we are going to move the point twice to the right. So it will be somewhere right here. And then the curve will still look like this. So this is 2 to the x and then minus 2. And this right here is at 2. And then continue. We are going to do the negative. When you multiply the function by a negative, if you get negative 2 to the x minus 2, you're just going to flip the function upside down. And then it's like this. You have the exponential function. You have the exponential function. Flip it upside down. That's what you get. Exponential function. Multiply a negative. Flip that upside down. All right? So this point will be down here, and then you will have the graph looks like this. Okay, and then lastly, we have to add the 5. So we are going to take this graph, go up 5 times. So, anyways, and then we go up 5 times. So it'll be somewhere like right here. But remember, this part right here is the horizontal asymptote, which is at 0, right? But once you go up 5 times, the horizontal asymptote will be at y equals 5. And then the graph will look something like this. So, no, that's horrible graph. just like that. Therefore, the range goes from negative infinity up to 5. All right? Now, this kind of things will already be complicated if you really like impose other functions with it. For example, if you decided to take the square root right here for the function there, the domain and the range will change. Right? The domain and range will change. So maybe you guys can remind me before we end the live stream today. We still have like almost 30 minutes. So maybe toward the end, if you guys want me to do the question like that, then just drop the chat, let me know. Right? But I'm not going to do that yet because I want to go over another one for a logarithm function, and then I also want to give you guys a sine cosine function for the examples. All right. So next one. How about let's just do this? Let's say you have 2 plus log base 2 of x minus 5, something like that. All right, domain and range. Domain and range. All right, so here's a question. Hold on one sec. When shall you make the decision to find the domain of the inverse in order to get a range of the original? When shall you make the decision? Okay, so far the functions that we're talking about, they are one-to-one except for the parabola. Like for exponential functions and logarithmic functions, they are one-to-one. Meaning if you just graph like say the exponential, if you draw horizontal line, the function passes the horizontal line test. That's one-to-one. Meaning one x value give you one y value. Sorry, one y value comes from only one x value. One y value comes from only one x value. But if you are talking about sine cosine, such as this right here, this is the sine curve. This is not one-to-one because if you draw a horizontal line right here, well, you can see that it passes the curve so many times, in fact, infinitely many times. So one y value comes from many different x values, so not one-to-one. Let's just say not 1, 2, 1. And this right here, yes, it's one-to-one. So if you're asking when shall we be restricting the domains to have the inverse, then for this right here, which is the sine function, we still want to have a nice inverse so that we can compute the angle, right? And things like that. Then we are going to restrict the domain to from here to here. And that is going from negative pi over 2 to positive pi over 2. Then in this interval here, it is one-to-one, and then you have the inverse. And in this situation, to find the domain and the range, you should really be focusing on the definition, the restrictions of the domain of the original for the range of the for the domain of the original, which is going to be the range of the inverse. There you go. So I think that's the question that you were asking. Okay. So now let's answer this. And I think many of you guys got it. So yay. Thank you so much for answering the question. Domain is 5 or, well, it's just 5 bigger than 5. So I'm just going to say 5 to infinity, not including the 5. Log of 0 is never defined, right? Range, just all real numbers. Just all real numbers. Yeah, you don't have to do too much work for that. You can do a quick graph, and let's just go ahead and get a final graph, right? So the graph of this is that when x is equal to 5, you have a vertical asymptote. So I'll put a 5 right here, like this, right? Log base 2, log base whatever, as long as you have a log base, this right here being bigger than 1, the shapes are going to be the same. Add a 2 to it, it's just a little bit higher, that's all. It's like something like this. I'll tell you though, when x is equal to 6, plug into here, you get 1. Log base 2 of 1 is 0. And then this right here will give you 2. Yeah. Because log of 1 is 0, because it was supposed to be like this. But since it went up 2 times, so that will be the picture. And still, the range is still all real numbers. And this right here, it goes up to infinity very slowly, but as what people say, slowly but surely. All right, so far we have gone over all the algebraic examples. Well, this right here, actually we still have to go over the fractional example, like the rational functions, but we did that a few live streams before. And those right there can get really, really crazy. I will also go over that real quick, okay? So here's the deal. Just real quick for rational functions, if you have a rational function, this is the case that you're expected to know, most likely. If you have ax plus b over cx plus d, just a linear function over linear function. And then I will have to tell you though, this right here, we don't want to just cancel them out because otherwise you just get 1. So for this right here, we don't want ax plus b to be exactly the same as cx plus d or like a constant multiple. I don't want that. Otherwise, we can reduce it. We don't want that. So assuming they're all different numbers, you cannot factor out anything, cancel anything, then this is all you have to know. Domain and range. Domain is the part that you make the bottom not equal to 0. So I'm just going to do this. You say cx plus d is not equal to 0. And you're setting out the restriction. And then you'll be able to find out the x value that you cannot use. Now, for the range, which is the main topic for today, it's just that y cannot be equal to a over c. In fact, when you have a over c, you get a horizontal asymptote, and the function will not cross the horizontal asymptote for this one. Sometimes a rational function does cross a horizontal asymptote, right? But for this one, when you have a linear over linear, that's pretty much it. This is the range that you have to worry about. This is, as I said, the simple case. And for example, real quick, if you have a function f of x equals, let's say, 2x plus 1 over 3x minus 2, the domain is just x cannot be 2 over 3. So you write it as negative infinity to 2 over 3. Do not include that, but pick it up from 2 over 3 to infinity. Now for the range, you look, that's also 2 over 3. Sorry, I don't like that. I didn't expect. All right, let's change it. Let's put 4. Oh, come on, didn't think about that. Sorry. 3x minus 4. Right. If you set the bottom not equal to 0, we don't want x to be 4 over 3. Now, for the range, you're looking at these two numbers. Y cannot be 2 over 3. Earlier it happens to be 2 over 3 as well. Anyway, so in this case, negative infinity up to 2 over 3, not including it, and then pick it up 2 over 3 to infinity. Just like that. So this is like the usual case that you should know. Why a over c? Because that is the horizontal asymptote. And to get that, you can actually do long division for it. So I'll explain that real quick. And again, I don't want any straightforward simplification, right? So assuming A, B, C, D are different, why that, right? So let's just do this. AX plus B over CX plus D. We're doing long division. So if you compare the first two terms, the first term on the inside and the first term on the outside, we have A. I need to divide I need to multiply something with the C to get rid of the C. So C will be on the bottom. I want to produce the A though. So A over C. If you take A over C times C, it's just A. And take this times X with, this you get A and X. Next, take this times that, just plus AD over C. And you subtract. This right here doesn't really matter. B minus AD over C, that's the remainder. But what we're saying is that this function can be written as A over C, and then you add the remainder. I'll put the remainder right here in blue. This is the remainder. I'll just put that on the top right here. B minus AD over C, and then over the original denominator. Now, when x is really, really big, goes to infinity, or negative infinity, this thing right here will approach 0, but it will not be equal to 0. So here, maybe just make a note of another. 1 over Cx plus D equals 0. This equation has no solution. No solutions. No. It will just approach 0, but it will have no solution, right? So this portion, it will be really, really small, but it's not going to be equal to 0. So the final thing that you are going to get is just that you have this portion, but you will never be able to reach that. That's why the y value will not include A over C, but anything else is okay. Yeah, another way to look at it is when x gets to infinity, you can ignore the B and the D. Yeah, so another way to look at it if you've done the limit. Yeah. So far, these are all the algebraic expressions that you have to know how to find a range, usually. Of course, there are different situations that you have to combine conditions together. Now, let's do the trigonometry ones. Mainly, you just have to know sine and cosine, and that's pretty much it. I'll tell you that, right? So for trig, this right here are the ones that you should know. Sine and cosine, sine theta, it's always in between of -1 and 1. And then if you have cosine theta, this right here will always be in between of -1 and 1. Usually that will be enough, but of course there are harder situations, such as when you divide them, sine over cosine, you get tangent. Here's a tricky question for you guys. What's the value here though? Anybody want to go give you a try for this? What is my next live stream on? I haven't thought about it yet. If you guys have any suggestions, I will be happy to hear them. It will be next Monday from 6:45 to 7:45. But make sure you guys go subscribe and at least keep an eye on the live streams, right? But subscribe to Chegg's YouTube channel so that way you get notified. Look, for this one, it's weird, huh? Because here, what's tangent? Tangent is like sine over cosine, right? Let me just write this down on purpose.
If you were born in 1010, then your astrological sign is dog.
What is this? I have no idea. Why is my phone? Anyways, sine over. Oh, I was talking about sine. Anyways, sine over cosine It looks like we're just doing, it looks like it's 1, this over that is 1, but no, cannot do that. Inequalities are tricky sometimes. No. In fact, this right here, you can write it like this, negative infinity to positive infinity. And that's of course for tangent. So the range for tangent, it's all real numbers. The reason why, it's because even though it looks like we're just dividing, but they do not share the -1 or the 1 at the same theta values. Sometimes when theta pi over 2, for example, when sine at pi over 2, you get 1, but pi over 2, for cosine, you get 0. And when you approach pi over 2, the function will go up. So that's why it gets to infinity. All right, but if you know this, that's actually pretty good. But let's do another one. Let's see if you guys can figure this out. How about if I multiply them? Sine theta times cosine theta. All right, so anybody know the answer for this? If you multiply them, what would you get? What's the minimum value and what's the maximum value? How do you get the domain for tangent theta? Well, remember, for tangent theta, this right here is the same as sine theta over cosine theta. So the idea is that we have a fraction, we have an expression on the bottom. That means we have to make sure the expression on the bottom is not equal to 0. So the domain is that we will have to say cosine theta cannot be equal to 0. And cosine, where it's going to be 0? If you think about the unit circle, x value is 0, x value is 0. So theta cannot be pi over 2. And if you go to the next one, is what? You just add pi, and then you can keep on going like this. And in fact, you can go whichever direction. So you will just say plus n pi, where n is an integer. And this right here is the domain for tangent. I use theta, but same as x. But how about for this one? Anybody know for this one? How do you get a range for sinh? Oh man, range. There are so many things we can talk about for range, maybe next time. But how about this one? Let's talk about this one first. Time traveler, you got it. It's from -1/2 to 1/2. This is pretty crazy, right? Because it's so deceiving. Because if you look at sine theta, cosine theta, right here, I'm just asking you to multiply them. So it looks like I'm just multiplying -1, -1, get 1. 1 times 1, get 1. No, it's not like that. All right. So for this right here, you will have to know that. How should I write it? Okay, I'm going to write this down on the side. We will have to utilize the identity that, so note, when we have sine of 2 theta, this right here gives us the double angle identity for sine, right? Which is 2 sine theta cosine theta. We have this part. We are going to divide that on both sides. So this right here is the same as 1/2 times sine of 2 theta. Now, based on what we said earlier for number 1 right here, sine theta is always in between of -1 and 1. Now, just have to multiply by 1/2. So this thing right here will be in between of -1/2 and +1/2. Just like that. So when we divide, when we multiply, say, oh, goodness, right? Okay, let me take a look what you guys have for this. What about polar coordinates and polar graphs conversions? Maybe next time. Yeah, that would be a good idea for trig. Yes. And all right, let's do one more. How about if we add them up? By the way, I should put on. We know this, but I want to put on the question right here. How about one more? Sine theta plus cosine theta. Okay. Let me see who can get this right. Secant and cosecant, you will just do the reciprocal, right? So I'm going to write that. Well, actually, I can write it down here. Okay, for cosecant theta, this right here is either going to be, when you do 1/1/, that's okay, right? You get less than when equal to -1, or cosecant theta is greater than or equal to +1. It's kind of like you're doing 1/1/1, and you split the interval. You split the inequalities. So you have either it's below -1, below or equal to -1, or 1 and above. But how about this one here? It's not -2 to 2. Again, we cannot just simply add them up because the -1 for the sine does not happen at the same theta value for cosine. So we cannot just add them up. Now, that's why I said it gets tricky sometimes. Correct. It's -√2 to √2. Oh my goodness, right? It's like, how did we even end up with a square root? Right? Okay, so we're going to utilize this right here along with the identities that we have seen before. I think I had gone over this like about last month during one of the live streams. Right here, this is how you can do it. So check this out. Sine theta plus cosine theta. If I can just write it as one sine or cosine function, our life would be so much easier, and it's actually possible. For this right here, look at this. This is like 1 times that, right? Yeah. But what I'm going to do is the following. I'm going to multiply this by square root of 2 because I don't really recognize the 1, but you will see this right here. I will have 1/square root of 2 times sine theta plus 1/square root of 2 cosine theta. If you distribute, it's the same as the original. Why did I do this though? Because this right here, we have that square root of 2 in the front. But for the 1/square root of 2, I will purposely write it as cosine of pi/4. And then multiply with sine theta. This right here, we can use the same angle, but I will use sine for it, which is sine of pi/4. And then times cosine theta. Now, we still have the square root of 2 all the way in the front, but sine theta, sine of the first times cosine of the second, plus sine of the second times cosine of the first. This is just the angle sum formula for sine. So I can write this as sine theta plus pi/4. Sine of the first times cosine of the second plus sine of the second times cosine of the first. So we have all this, and remember, sine of whatever angle that you don't care, this right here is in between of -1 and 1. Now you just have to multiply by square root of 2. So that's why this thing here is in between of negative square root of 2 and positive square root of 2. And that will be the range for this function. Yeah, this right here is very, very fun, right? All right, seriously, a lot of more things that we can talk about with the range for the trig functions. Perhaps let's try to do 2 more before we go today though. How about this right here? Ready? How about if I do sine squared theta plus cosine squared theta? How about this one? And then in the meantime, let me also write this down. How about if we have sine to the third power theta plus cosine to the third power theta? Okay. All right. So this is number 1. This is number 2. 2 questions for you guys. We do have about like 4 more minutes. So I just want to tell you guys that remember we'll be back next week. We will have live streams on Mondays from 6:45 p.m. to 7:45 p.m. until the end of May, because I think that's the end of the semester for most of you guys, right? But next week, I will be hosting the live stream on Chegg's channel. So make sure you guys scan the QR code right now so you can go subscribe to Chegg's YouTube channel and also check out their social medias. And if you have other questions, if you are studying chemistry, physics, go ahead and check them out to see what they have to offer for you. All right? Then thank you guys so much for coming. For the last 3 minutes or so, I will let you know the answer for number 1 and number 2. So just put down that question 1 is between what and what, and then question 2 is between what and what. Number 1 is just like a squeeze theorem, that kind of thing, right? This right here, surprisingly, well, it's just 1 and 1. Anyways, though, this right here is just, I will say sine squared theta plus cosine squared theta is equal to 1. Exactly. So the range is just 1. It's just a horizontal line. But for the cubic one, sine cube plus cosine cube is slightly different. If you want to write this as an interval notation, if you put this as 1, 1, that I don't know what to say about it, because it's just one number. So maybe for the range for this right here, I will put like it's just a set of the number 1. You just have 1. It's not even interval, it's just a number. It's just 1. So yeah. Yeah, this right here is true for all theta, but only the real numbers. If you have a complex number for theta, yes, you can get different values. But how about number 2? If you have the cubic ones, I'm debating to see if I want to tell you guys the answer today or maybe next time. So that way you guys can think about how to deal with this. All right, so let me just kind of read through what you guys have. We do have 2 more minutes, so if you have anything you want to say to me right now, just go ahead and leave in the chat. I'm reading it. You can also answer the question for this right here, right? Thanks as always, Professor Steve. Thank you so much too, Stefan. Thank you. Okay, let me see what you guys have. Thank you so much. Mr. Pen, how am I? I'm doing good. I'm doing good. Thank you for joining us today. Thank you guys so much. And then please go over verifying trig identities. Okay, yeah, because trig identities are hard, right? So yeah, definitely we can do that. Maybe we can also do the polar coordinates identity. And remember, next week, you will not see notifications from my channel because I will be doing live on Chegg's channel. So make sure you guys scan the QR code and just subscribe. I think that's going to be easier so that you can get like you can get notified once the live stream's on. But it's going to be the same time. We still have about like 4 more times for until the end of May. So about like 3 or 4 more times. Yeah. Okay, I think that'll be it for today though. Next week. All right, bye everybody.